Here are two video calls. Same sentence, same 4 seconds. Watch the first one. It freezes. The timer keeps counting. Nothing arrives for about 400 milliseconds. Now the second one. It glitches. But the voice never stops. Neither of these is broken. One was told to wait for data that hadn't arrived. The other was told to lose it and keep going. One of these protocols will lose your data on purpose. The question is what that bought. Almost everything you use runs on one of two protocols. TCP, the transmission control protocol. It promises every byte arrives in the order you sent it. If something goes missing, it notices and fetches it again. UDP, the user datagram protocol. It promises almost nothing. It sends a packet and forgets it existed. No ordering, no retrieves, no connection at all. Both of them sit on IP, which only knows how to move a packet. Everything from here is what those promises cost you. Here's that same traffic on a clock. Time runs left or right. The sender is along the top. Two receivers underneath. One speaks TCP, one speaks UDP. 8 packets leave. 8 lines draw across. All 8 arrive. At both receivers. At exactly the same instant. Now, the sentence everyone repeats, UDP is faster. Nothing here is faster. Bits move at the speed of the link. Neither protocol touches the link. Nothing has gone wrong yet, so nothing is different yet. Open one packet up. This is a UDP header. 8 bytes, all of it. Where it came from, where it's going, how long it is, and a check that it wasn't mangled on the way. That is the entire protocol. Here's TCP's. 20 bytes before options. Every extra field is a promise. A window so it can be told to slow down. A number that says what it already got. And this one, where this packet sits in the stream. That field is how it knows something is missing. Rewind the clock to 0. Before your first byte, TCP does this. One packet that says I'd like to start. One back that says go ahead. And one more that says starting. 3 packets, one full round trip. Put a number on it. Say the round trip is about 150 milliseconds. That's about 300 milliseconds. Before a single byte of yours moves. UDP's first mark on the clock is the dative. One round trip earlier. This is the one place UDP is genuinely faster. Send one small thing and it dominates. Stream for a minute and it's a rounding error. Now let one go missing. Packet 4 leaves and stops. 5 arrives. 6 arrives. 7 arrives. Watch the UDP side. 5, 6, 7. Handed straight to the application. Now watch the TCP side. 5, 6 and 7 arrive. And stop. They're sitting in a buffer. The application can't have them. Not because they're lost, they're right there. Because 4 is in and TCP promised order. One missing packet holds up everything queued behind it. How does the sender even find out? The receiver keeps acknowledging 3. 3, 3, 3. Because 3 is the last thing it has in order. 3 of those and the sender resends immediately. And when nothing comes back at all, there's nothing to count. So TCP falls back to a timer. Usually a floor in the low hundreds of milliseconds. And it doubles every time the retry fails too. Watch it elapse. The gap is wider than every packet before it put together. Nothing is delivered for that entire span. Then 4 arrives. 4, 5, 6, 7 delivered all at once. Even arrivals came out as a stall and a spike. Back to the 2 calls. Now you can see what made them. The freeze was that buffer waiting. Nothing was wrong with the connection. The picture had nowhere to go until 4 turned up. The glitch was a codec handed a hole. It guessed and got it visibly wrong for a moment. Then it moved on. In a live call, here's what actually matters. Data that arrives 400 milliseconds late describes a moment that has already gone. It isn't degraded, it's worthless. So losing it was the right call. You didn't give up accuracy. You gave up the right to decide what a loss means. All of that in real code. One line. Socket, internet, stream. That's TCP. Same line again. One word different. Datagram. That's UDP. Everything you just watched is on one side of that word. None of it is on the other. So the second one hands you 3 questions. Does order matter here, and is a loss survivable? And if it isn't, who retries? Because it won't be the protocol. There's one more promise nobody lists. Let the clock run for 6 seconds. Watch TCP's rate. It climbs. It hits loss. And it halves. Then climbs again. It's reading the network and backing off. Now UDP's rate. A flat line at whatever you told it. It doesn't know the network is in trouble. So a naive UDP app on a bad network can be worse than TCP. You didn't remove the problem. You removed the code that was handling it. So which one do you actually pick? 4 cases. DNS, 1 question, 1 answer. A lost packet costs you a retry worth milliseconds. A connection would cost more than the thing it protects. UDP. Voice and video. Late data is worthless. You saw why. UDP. A file, an API call, a database write. Every byte in order or the result is garbage. TCP, there's nothing to decide. Games, UDP plus a few bytes of their own reliability. On only the messages that genuinely must arrive. The question was never which one is faster. It's what a missing packet means here, and only your application knows that. Back to that stall one more time. TCP wasn't slower, it was waiting. The why was the same speed the whole time. And there's a last thing worth knowing. HTTP 3, which your browser is probably using right now. It runs on UDP, and it rebuilds ordering itself. But per stream. 3 streams, one loses a packet, that stream stalls. The other 2 keep delivering. The hole is still there. It just doesn't block anything behind it. Reliability was never one switch. It's a set of promises. And now you can pick them one at a time. If that changed how you read a protocol, subscribe. There is a new one of these every week. Next time, the 5 places your data is already cached. You wrote none of them.